Okay, so this presentation is on Module 4, Topic 8. So this is about the accuracy of measurements. The topic begins on page 92 in the August edition of the workbook. And the topic, it's not covered in the OLI textbook. They may assume you already know about this. I find that later in the semester, it's easier to explain margin of error if we have this little conversation now about accuracy of measurements, and it's not a complicated thing at all, so we may as well just throw it into the mix. So now it's written up in a lot of detail in the workbook, and I think you should read the workbook. It may look more complicated in the workbook than it is just because of the way it's written up in detail. So what I'm going to give you in this video is a presentation with, the spoken word and more pictures, and sort of get to the point, and then maybe afterwards look at the discussion in the workbook. And there's a related topic. I'm doing topic 8 today. I'm not going to talk about topic 9, but you could read it in the workbook. It's a closely related concept. It's not accuracy of measurements, it's precision of measurements, and that's a slightly different thing. So it may be useful to read the other topic as well, just so you don't get the two things mixed together. But the one that will be relevant to what we're doing in the next couple of weeks is just the accuracy. Okay, so I want to change the picture here, just a minute. Yep. Okay, so this is the workbook, page 92. So this is where you'll go. It might be a slightly nearby page. I put out a couple of different editions of the workbook, and I'll be replacing, the edition in your Canvas in a couple of weeks with an update. But anyway, so this is what it looks like in the workbook. And then here's the PowerPoint presentation, and I want to just talk through that now. So, a continuous variable can have all the different little fractional values. So you might not just get a 3 or a 4, you might get 3.1234987 with just as many digits going on forever in principle. Your measuring device will only ever show you a few of those digits, but we imagine that the other digits exist in some sense. We just can't measure them accurately enough. So when you write down a number from a measurement in a science class, maybe you have a little lab notebook and you're weighing some things and you mark down the weight, you're having to cut it off somewhere. And you certainly don't want any irrational numbers that go on forever, or fractions that don't go on forever but just go on too long. I don't know what that sound was, but okay. So how long is this this stick of staples? You look at it. I didn't really want to put the 6.8 up there, but you can look down here and you can see it's about 6.8, but it's maybe in between. It might also be close to 6.9. The point is, we don't know exactly. Okay. We think 6.8 is the closest to the real value. So if you were in a science class and you wrote down in your lab book 6.8, that would be the right thing to do. You've not made any mistake, but a person reading your entry would understand that you don't mean it exactly. If you write that x equals 6.8 in science, not in algebra. In algebra, you mean 6.8000. But in statistics or science, if you write that it equals 6.8, everybody knows you don't really mean it. And this is what you actually mean, that x is between 6.75 and 6.85 inches. X is greater than or equal to the 6.75 on the left-hand end, but strictly less than 6.85 on the right-hand end. And so you don't have to write that every time. You just say x equals 6.8, but everybody knows it's a range of possibilities. And so to get from the 6.8 that you wrote down over to the really correct answer, which we don't know, you might have to add or subtract some unknown amount. You might have to add or subtract as much as 0.05 centimeters, or subtract 0.05 centimeters. So you recorded it to the nearest tenth of a centimeter. When you wrote down the 6.8, you stopped in the tenths place. That's 8/10 of a centimeter. So you recorded it to the nearest tenth. Half of a tenth is 0.05. So that's the plus or minus that much that you might have to add or subtract. So another way to write what is the true length, you say 6.8 plus or minus 0.05 centimeters. And if I asked you, how accurate is this measurement? You would say, it's accurate to the nearest 0.1 centimeters. If all you have to go on is just how many digits were written down. Now, sometimes somebody might write down 6.8 centimeters and then they make a note and they say plus or minus half a mile. And that's how accurate it is. But if they don't say anything else, the assumption is that it's the plus or minus 0.05 because the number, whatever the true number was, it just rounded to 6.8. So you can determine the accuracy of a set of data by counting the digits to the right of the decimal point. This data is accurate to the nearest tenth of an inch because the units of measurement are specified in the top of the data column. It says inches, and then these digits, the data, stop in the tenths place. And ordinarily, you want all of the data in your data set to be equally accurate. Sometimes one of the values is known better than the others, but usually not. Usually it's a mistake with the display format if you see different numbers of digits. Okay, so what's the diameter of tree number 2? You say, well, it says right there 0.8 inches. Sort of. It's about 0.8 plus or minus 0.05 inches. This data set has 2 digits to the right of the decimal point. How accurate is it? So you got to listen to the language here. I know you've got the concept, but I know in class, if I ask people, so how accurate is this? Get somebody to raise their hand. They're not sure how to say it, And so how do you say it? You say, it is accurate to the nearest hundredth of a milligram per liter. The units are part of it. Accurate to the nearest hundredth of a milligram per liter. Or plus or minus 5/1000ths of a milliliter. So that first bottle number 1 in the data set, has a concentration of about 0.44 milligrams per liter. plus or minus 0.005 milligrams per liter, and it is accurate to the nearest 1/100th of a milligram per liter. Now this data has no digits to the right of the decimal point. How accurate is it? How do you say that? You can say it's accurate to the nearest whole pound. What's the weight of player 3? It's about 166 pounds, plus or minus half of a pound. Because those are all, that whole range of weights from 165.5 up to 166.5 would round off to the 166. We don't think that the player had exactly 166 pounds weight. That's the end of the slideshow. That's all for this presentation, and I'll see you in the next one.